Chapter 7.5 is proportions in triangles. Our first essential understanding is when two or more parallel lines intersect other lines, proportional segments are formed. And the other essential understanding is the bisector of an angle of a triangle divides the opposite side of two segments with lengths proportional to the sides of the triangle that form the angle. So let's get right into what all of this means. The first theorem is 7.4. It's the side splitter theorem. And what this says is if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So I have a triangle, and I have a line that's parallel to one side of the triangle. So RS is my parallel line, and it intersects the other two sides. Then it divides those sides proportionally. So XR to RQ is equal to YS to SQ. And let's go ahead and practice this. So problem 1 is using the side splitter theorem. It says what is the value of X in the diagram at the right? We're going to set this up so that PK to KM is equal to NL to LM. So X plus 1 to 12 is equal to X to 9. And we solve this by cross multiplying. 9x plus 9 equals 12x. And then simply solve for x. So x equals 3. All right, the problem 1 got it. What is the value of A in the diagram below? So using the side splitter theorem, I know that A to A plus 4 is equal to 12 to 18. So let's solve this by cross multiplying. And then solving for A. So A equals 8. The corollary to the side splitter theorem says if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So we have three parallel lines, and we've got our two transversals. It says the segments intercepted on the transversals are proportional. So AB to BC is proportional to WX to XY. Problem 2, finding a length. Three campsites are shown in the diagram. What is the length of side A along the river? So site A, we are looking for this distance right here. We'll call that X. So to set this up, I'm going to say that X to 9 is equal to 8 to 7.2. We're going to cross multiply and divide. So I set this up so that I had X to 9 and then 8 to 7.2. I could also set this up X to 8 and then 9 to 7.2. If I were to do that, I would come up with the exact same answer. The only thing that's changed is my placement of the 9 and the 8. And remember, we can do that in these proportions. So the same solution would be found no matter how you set this up, as long as you set it up in the same way. The problem 2 got it. Three campsites are shown. Again, we're looking for the length of site C along the road. So this time we're looking for this information right here. We'll call that X. And I'm going to set this up so that I have 8 to 7.2 is equal to 6.4 to X. So X equals 5.76. For this one, I also could have set this up 8 to 6.4 equals 7.2 to x. Again, that would give me the same answer. The most important thing to remember when setting these up is that you're consistent. So if along here, you know, top to top, bottom to bottom. Next is Theorem 7.5, the triangle angle bisector theorem. It says if a ray bisects an angle of a triangle, then it divides the opposite sides into two segments that are proportional to the other two sides of the triangle. So we've got our triangle, we've got our ray, and it bisects the angle. So these two are congruent. It says that it divides the opposite sides into two segments that are proportional. So these are proportional to these sides. So CD to DB is proportional to CA to BA. Problem 3, what is the value of x in the diagram at the right? The first thing to look for is make sure that our ray PQ actually bisects angle P, and it does because I can see that these two angles are congruent. So we can set this up, and let's just say that 10 to 12 is equal to 18 to x. So cross multiply. And x is equal to 21.6. And the problem 3 got it. What is the value of y in the diagram below? Let's go ahead and set this up. I have y to 9.6 equals 24 to 16. Go ahead and cross multiply. And divide. So y equals 14.4.